Good morning all. Today we are going to study about the concept of embedded programming. As part of your syllabus, previously you have studied about the embedded hardware. But hardware is not enough for an embedded system. Along with the hardware, a good software also needed. And in the case of embedded system, the software is called firmware. These are the topics we covered in this lecture. First one is Introduction to Embedded Programming. Here we will see various embedded programming languages such as C, CPP, Java, Python, etc. And we will understand what are the advantages of each programming languages. And then we will move on to Embedded C++. Embedded C++ is a subset of ANSI C++, and it contains many features of ANSI C++. So for optimization purpose, the embedded C++ removed some of the features of ANSI C++, and we will see what are the features which is removed from the ANSI C++ to obtain embedded C++. An embedded system consisted of both hardware and software. The hardware part contains a processor, RAM, ROM, various actuators and sensors. And the software is the algorithm which is implemented in machine language. In the case of an embedded system, this software is called firmware. And every embedded system should have one software. Without the software, the embedded system cannot work. And this software tells the embedded system how to behave with different sensed input and how to act using the actuators. And this firmware can be obtained by compiling the source code. And this source code can be written in any of the programming languages such as C, CPP, Java, Python, etc. If we use C or CPP, we need a compiler to convert the source code into the binary format. And this compiler should be an architecture specific compiler, because if our embedded system is version 7, the compiler should be version 7. But in the case of interpreted languages such as Python, there won't need any compiler, because the interpreter in the embedded system can directly run the Python code, the source code. Before starting an embedded programming, we should consider following characteristics of an embedded system. Firstly, the embedded system doesn't have a user interface. Sometimes it may have, but normally it doesn't have a user interface. For example, if you consider an air conditioner, the air conditioner has not equipped with a monitor or a mouse or a keyboard. The problem with the lacking of this user interface is that the validation and testing of this embedded system is very difficult. If some error or some problems happen with this embedded system, then it is very difficult to understand and find out the issue. And the second characteristic of the embedded system is it has limited hardware resources. It means that the processing power of the embedded system is very low. It may have the processor with a few megahertz of clock frequency, and it has RAM of few kilobyte. In such cases, the embedded software should be made super efficient so that it can perform well. And the third characteristic of embedded system is the executable code we created should be burnable to the ROM. We know that the ROM size of an embedded system may be in the range of few kilobytes. So that if the source code we generated, if the machine code we generated by compiling the source code is higher size than the ROM, then we won't be able to burn the source code into the ROM of the embedded system. These are the commonly used programming languages, and we will see which of these languages is more suitable for programming our embedded system. Firstly, the assembly language. The assembly language is a low-level language, and the program written in the assembly language can be converted into machine code using a assembler. But people not prefer assembly language for coding an embedded system because it is very difficult to code and test and debug the program written in assembly language. So people normally prefers C and C++ over assembly language. This C and C++ are compiled language. It means that the program written in the C and C++ can be converted into corresponding machine code using a compiler. And the code size, the machine code size obtained after compiling this C and C++ is very small, and the performance of this machine code also is high. Hence, for lower configuration embedded system, people prefers to C and C++ for programming the system. But if the configuration of the system is high, so it means that if the memory capacity of RAM may be higher than 100 megabyte and processor has a high clock frequency, in such cases we can use Java and Python and or other interpreted language for programming the embedded system. If we are using Java for programming the embedded system, we need a Java runtime environment working and running in the embedded system, and the source code should be converted into Java bytecode by compiling using a Java development kit, and the compiled Java bytecode will be fed into the Java runtime environment working in the embedded system. Similarly, if we are using Python, then there should be Python interpreter in our embedded system for running our Python code. Many of you have familiar with the embedded C. Embedded C is a embedded version of C language, and it is specialized for embedded system. But C is a function-oriented language, and sometimes it is difficult to program in a function-oriented language than object-oriented language. So many people prefer C++ over C, and the embedded version of C++ is called embedded C++, and embedded C++ is optimized for embedded systems, and it is an object-oriented language, so it has many perks of object-oriented language, and it is defined by a group of Japanese CPU manufacturers like NEC, Hitachi, Toshiba, etc. Now we will see what are the goals of embedded C++. There are 5 goals for embedded C++. First one is to make the specification as small as possible while retaining the object-oriented features. We have already said that embedded C++ is a subset of C++. So many of the features in the C++ is removed in embedded C++. But the object-oriented related features is still there in the embedded C++. And the second goal of the embedded C++ is to avoid the excessive memory consumption. You all know that the embedded system is a resource constrained system. It have less powerful processor and low memory capacity. So we should ensure that the memory consumption should be low. And the third goal of the embedded system is taking care not to produce unpredictable responses. And the fourth one is the making code roamable. Here it means that this machine code generated by the compiler should be small so that it can be burned into our ROM. And the last goal of the embedded system is non-standard extension to C++ should be avoided. Now we will move on to syntax and semantics of embedded C++. I already said that the embedded C++ is a subset of C++. It means that many of the features present in C++ won't be available in embedded C++. So we will see which features is not included in embedded C++. The first feature which is not included in embedded C++ is mutable specifier. Mutable specifier is a storage class specifier, and it tells that the value of the object or variable can be modified. So if mutable is specified before an object or a variable, then this object and variable cannot be put into ROM. So it is avoided in the embedded C++. Similar to mutable specifier, the exception handling is not included in embedded C++. Exception handling is a good feature of C++. It helps to deal with the errors arises during the execution of a program. When an error comes, the CPU will execute the exception handler in C++. But in the case of embedded C++, it is removed because the exception handler required extra CPU resources and memory resources. But the resource limited embedded system, it is not possible to give the required amount of memory and CPU time for the exception handling routine. Another features which is removed from the embedded C++ is runtime type identification. It is the feature in which the processor obtains the type information of an object during the runtime, and then it comes template class, which also not included in embedded C++. This says that the template class cause unexpected code explosion, so they have removed template class. Then the multiple inheritance and virtual inheritance is also removed from embedded C++, because it is says that even for expert program, it is difficult to design a class hierarchy using multiple inheritance. So they have also removed the multiple inheritance and virtual inheritance in embedded C++. Along with the features, many libraries are also removed from embedded C++. The first library they removed from embedded C++ is file operations library, because file operations is OS dependent. Hence they removed the file operations library. Then they removed some character types. One is wchar type and other one is long double. Wchar means the Unicode, wchar underscore t means it is a Unicode type, and long double means is a higher precision floating point number type. Both are removed in the embedded C++, because these two type has very little use for embedded application development. And another library they removed from the embedded C++ is STL library. It means standard template class library, because template class there is no template class in embedded C++. There is no requirement of STL library. Now we can see the summary of today's lecture. First we start with the embedded system programming, and the program written for embedded system is called firmware, and it is stored in read-only memory of embedded system and or flash memory. And every embedded system has a limited hardware resources, so the firmware should capable of executing the program with this limited resources. And then we seen what is embedded C++, and we understand that the embedded C++ is a subset of C++. Since embedded C++ contain same syntax and semantics of C++, a programmer with C++ knowledge can do a embedded C++ program. And in this embedded C++ is designed specifically for embedded system, and it can run with the limited hardware resources of embedded system. Thank you.